Swayam Prabha. Digital India. Educated India.
So, in my previous lecture, I have discussed about the densification to mitigate the seismic or liquefaction hazard. Now, I have also discussed there are basically 4 methodology by which we can improve the ground to mitigate the seismic hazard, mainly the liquefaction. So, those are densification, reinforcement, drainage and solidification. Now, I have discussed in my previous lecture about the densification, and there are few methods by which we can do that, that vivo-compaction, blasting, dynamic compaction and then compaction grouting. Now, today I will discuss about the reinforcement. Okay, so reinforcement can be done by compaction piles. Right now, I am discussing about the compaction pile. Later on, I will discuss about the another method, that is a common method where we can incorporate the densification effect, reinforcement effect, drainage effect. So, now this is compaction piles. Compaction piles are generally pre-stressed concrete or timber piles that are driven into loose sand or gravel deposits. The flexural strength of the pile prevents the soil movement. So, that means it provides the reinforcement effect. So, it because of its strength, flexural strength, the soil movement can be prevented. So, that is why it is a reinforcement technique. So, we are inserting the piles into the soil so that the movement of the soil can be restricted by this reinforcement effect. Vibration and displacement during installation of pile densify the surrounding soils. So, that means during the installation, so if you are using it for loose sand, so during installation there will be vibration and displacement. Because of that, some densification effect will also come into picture. So, that means it is a combination of densification effect and reinforcement effect, but the majority is the reinforcement effect. Okay. So, range is 7 to 12 times the pile diameter. So, that means that this densification effect is placed surrounding the soil surrounding the pile about the range of 7 to 12 times the pile diameter. So, that means the soil surrounding the piles of range 7 to 12 times of the pile diameter can be densified during the installation process. Now, the lateral stress in the surrounding soil increases due to installation of the pile. The relative density of the soil between the pile can reach a value up to 70 to 80%. So, this is also done in the grid pattern. So, the soil in between the piles can be densified up to 75 to 80%. Okay. So, this can be densified, or the relative density of the soil in between can be reached up to a value of 75 to 80%. The soils up to the depth of 18 meter can be improved with reasonable economy. Okay. Now, the next one is the drainage. So, this technique can be also used for liquefaction mitigation, and in the later stage I will discuss in detail about this drainage technique. Okay, now we will come to the solidification. So, solidification can be done by grouting. Okay. So, there are different types of grouting techniques, that is your permeation grouting, intrusion grouting, compaction grouting, jet grouting. So, about that compaction grouting I have already discussed. Now I will discuss about the other types of grouting. The first one is the permeation grouting. So this particulate grout, so for example the aqueous suspension of cements, fly ash, bentonite, microfine cement or combination, or chemical grout that is used for fine sand are used. Okay, so that means the in permeation grouting, the particulate grouts, for example the aqueous suspensions of cement, fly ash, bentonite, microfine cement or the combination of these, or the chemical grout that is used for fine sand or are used for this grouting technique. The chemical grouts generally have relatively lower viscosity than the particulate grouts. The presence of fines can significantly reduce the effectiveness of the permeation grouting. So that we remember that the presence of these fines can reduce effectively the effectiveness of this permeation grouting technique. Grouting is done in a grid pattern with a spacing of 1.2 meter to 2.4 meter. The use of grouts strengthen the contacts between the individual particles or soil grains and make the soil skeleton stronger and stiffer. So as I have discussed in my previous lecture, that it make it a solid material. Okay, so that means this, when you use this grout basically strengthen the contacts between soil particles, so that the soil skeleton becomes stronger and stiffer. So voids between the soil grains are filled by the grout material, which reduces the tendency for densification or generation of excess water pressure due to cyclic loading. Now, if the soil is loose and then there is a void, so now when it's a saturated soil, say, and during the cyclic loading, because of the presence of this water pressure within the voids, so there is a possibility of generation of excess positive water pressure. Okay. Now, if these voids are filled with ground material, that means those generation of excess water pressure is been reduced, and because of this densification, because when the seismic load is applied, so the soil densifies. Okay, and then if there is a void amount is more, and there is a possibility of densification, there is a possibility of generation of excess water pressure, positive water pressure. So because of this grout material fill this void, so that means the generation of this excess water pressure possibility is being reduced. So this is permeation grouting. Next one is the intrusion grouting. Okay, so grout are here injected in the soil under pressure for control fracturing in the soil. So that means here these grout are injected into the soil under pressure to do a controlled fracturing in the soil. The relatively viscous cement grout can be used. The strength and stiffness of the soil can be increased due to the hardened network of these intersecting grout lenses, which can be formed by repeated intrusion grouting fractures. So that means we are actually fracturing this control fracturing is done in the soil, and the strength of the stiffness of the soil can be increased, and then we are how it is been increased, because we are applying this relatively viscous cement grout and under pressure, and then we are doing this fracturing. Now these strength and soil of this soil can be increased due to the hardened network. So that means due to this fracturing, there is a network that is been hardened of this intersection ground lengths, which can be formed by repeated intrusion grouting fracture. Then we do the repeated fracture, intrusion grouting fractures, and the strength and soil can be increased due to hardened network of this intersecting ground lenses. Okay. And then the next one, that is for solidification, another technique. Solidification, one technique is grouting. Out of that I have discussed three types. Compaction grouting is densification. Compaction grouting is in densification. Okay, so here grouting four methods are given, but that is, and for the solidification purpose we use the permeation grouting and the intrusion grouting and the jet grouting also, but that is in another heading, that is for mixing. But this compaction grouting is generally used for the compaction mechanism or densification purpose. So now here we will go for the mixing. The improvement is done with columns prepared by mixing of soil and cementitious material. So that means here soil columns are being formed. How these columns are formed? They are mixing with soil. The soil is mixing with cementitious material. The cementitious materials is mixed physically with soil. Thus, strong cement slurry is used here. Okay, here it is physically mixed. That's why the strong cement slurry is used. Can be done by soil mixing or jet grouting. So that means the jet grouting is also used for the solidification, but it is in the form of mixing, where the soil column is being used or is being formed. Okay, so that means out of these four grouting techniques, that permeation grouting, intrusion grouting and jet grouting are used for the solidification purpose, and compaction grouting is used for densification purpose. These are generally, okay. So now the soil mixing. The first one is the mixing, soil mixing, next one is the jet grouting. In the soil mixing technique, soil is mixed mechanically with cementitious material, as I mentioned, cement slurry, using hollow steam auger and paddle arrangement system. Uniform soil cement columns are formed. Wall or cellular type of structure can be constructed below the ground surface by overlapping the column. So that means we are basically overlapping the columns each other. So that one column, then we overlap the another column. Though if I construct this type of arrangement, then it will form a wall, column wall, okay, or a cellular type of structure. So that means the one column is constructed, then the another column, but when the next column is constructed, it has some overlap with the first column, and so on. So that means we can form a wall or the cellular structure below the ground surface. This technique can be used for any type of inorganic soil. This technique has been used up to 20-meter depth in US and up to 60-meter depth in Japan. Now in the jet grouting, next one is the soil mixed with cement grout is injected horizontally under high pressure in a borehole. Okay, so here under high pressure, the soil mixed with cement grout is being injected horizontally in a borehole in all directions. So that means first a borehole being constructed, then within the borehole at different depth, these grout, cement grout is being injected horizontally. That means it go in the lateral direction, any direction or all direction, horizontally. Okay, air and water can be injected to help the mixing process. Jet grouting is done from the borehole bottom to top to form a uniform soil cement column. Okay, so now when this is been horizontally injected in the borehole, so it starts from the bottom and then it starts from the bottom to top to form a uniform soil cement column. Wall or cellular type of structure can be constructed below the ground surface by overlapping the columns like your soil mixing. Then soil column diameter in coarse grain soil are generally larger than fine grain soil. If only grout is used, the diameter is in the range of 0.4 meter to 6 meter in clay silt soil and 0.9 meter to 1 meter for sandy gravel type of soil. If grout and air and water are used, sometimes as I mentioned, the air and water can be injected to help the mixing process. Now, if only grout is used, then the column range is 0.4 meter to 0.5 meter for clay silt and 0.19 meter to 1 meter for sandy gravel. But if grout and air and water are used, then the diameter is in the range of 0.8 to 1 meter for silty clay silt and 2 to 2.4 meter for sandy gravel. So, it can be increased, okay, because it will help this mixing process. This technique can be used for any type of inorganic soil, okay. So, now these are the all methods, that 4 techniques I have discussed, and among these 4 techniques, what are the different methods by which we can do that densification, reinforcement, drainage and the solidification. But the drainage thing I didn't explain in detail. Now, I will discuss the drainage part. So, drainage, I have discussed the drainage techniques. Mainly we can use the stone column or we can use the PVD or for this drainage. So, drainage is what is the mechanism? That in the soil we provide the drainage path, so that when there is a excess water pressure is will be generated, so that it will get a travel path to dissipate from the site, so that the possibility of liquefaction can be reduced. Okay. So, that is the function of drainage. So, when we talk about the drainage technique, so that is the stone column is most commonly used. So, that means in the stone column, the major function is the drainage, as I mentioned. Suppose when I talked about the reinforcement, I used that your compaction pile. So, major function of that you can see, that is the compaction pile. Major function is reinforcement, but in addition to that, it will serve as the densification purpose also. Now, here the stone column major function is the drainage, but in addition to that, there is, it can act as a stiffening material or the reinforcement and densification purpose also. So, one by one I will discuss. So, this part in detail, because here we have some design charts available to design this system to mitigate the liquefaction of the ground. So, that is why this part I will discuss slightly in detail. So, that means first that I have mentioned that this is the first function is the drainage. Next, it can act as a reinforcement function also, and then it has the densification function also is there. So, that means what is stone column? In the stone column, so there are these columns are inserted into the ground, and then these you can see, this is the cross section of stone column. This is in lap scale, and then these are the top view or the plan or the arrangement of the stone column. These columns are also used in grids. There can be a triangular grid or the rectangular grid. Here it is in the photographs, it is in the rectangular grids, and this is a close view of the stone column. So, some properties are that in the diameter of the stone column generally varies from 0.5 to 1 meter, and in the broader range 0.4 meter to 1.2 meter, but generally 0.5 to 1. For loose sand, it is around 0.8, because the loose sand, which is the where I will mainly use the stone column to mitigate the liquefaction hazard, where the standard diameter range is 0.8, but not only in the liquefaction, this technique can be used for the soft clay also to accelerate the consolidation, and as well as it will act as a reinforcement material. Okay. So, there that is also drainage is the main issue, and then it will act as a reinforcement material. So, it will increase the stiffness of the soil, overall stiffness of the soil. So, but that part I am not discussing here, because that is for soft clay for consolidation purpose. Here it is if you use in the loose sand for to mitigate the liquefaction. So, that is why we are using it is as a mitigation technique for liquefaction hazard. So, that means but this range 0.5 to 1 that depends on the type of soil. For the loose sand it is around 0.8 meter. The spacing is generally used for 1.5 meter to 3 meter. So, this grid spacing. The length it can go up to 20 meter, but in some cases it can go up to 30 meter depending upon its use. Now, particle size, we are talking about that this column there is a these stones are inserted into the ground. So, this is the gravel particle size is 20 mm to 75 mm. Okay. Now, there are different installation techniques available. Okay, there is dry method, wet method. So, depending upon the soil type, because remember that our is the loose soil, depending upon soil type, site condition, we will decide which type of technique we will use to install this stone column. Clear? So, that means right now I will mainly concentrate on this design part. Okay. So, this installation, all these techniques in detail I am not discussing, these are available in your any ground improvement course. So, I will only concentrate on that how we can design this stone column improved ground to mitigate the liquefaction hazard. So, this geotechnical earthquake point of view I will discuss only that part. Now, because these installation these are common, because this is a very common ground improvement technique. So, that means any ground improvement technique course you will get all this information, but I will only concentrate on the design. So, but I am giving you the basic information related to the stone column, all the things those are required for this design. Now, as I mentioned, these are the properties. Okay. So, now what are the different functions? As I mentioned, if it has the mainly two functions, drainage and the reinforcement. If it is being used for drainage purpose, then it can accelerate the consolidation of clay. That can be used for the consolidation, reduce the consolidation time. Now, another one that liquefaction mitigation in loose sand deposit. Yeah. So, that means here it acts as a drainage path. So, in the consolidation also the clay or permeability is very less. So, if I install the column, it will provide a drainage path so that the consolidation time can be reduced, or for the faster consolidation. Similarly, in liquefaction also it will provide the drainage path so that the generation of excess pore pressure during the earthquake or after the earthquake can easily dissipate from the site. Now, if it is used for the reinforcement purpose, then it can increase the bearing capacity and reduce the settlement. Clear? So, now here we are mainly discussing about the liquefaction mitigation in loose sand deposit. Now, stone column effect, what are the different effects of stone column? That means it is a stiffening material. So, that means it will act as a reinforcement purpose. So, that means why it will increase the stiffness of the soil? Because the stiffness, overall stiffness of the soil, because the stiffness of the stone column material is more than the stiffness of the surrounding soil. So, stiffness we are expressing in terms of elastic modulus. That means the EC value of stone column or E value of stone column is greater than the E value of surrounding soil. And compressibility, so that means if the stiffness of the soil stone column is more than the stiffness of the surrounding soil. So, definitely the compressibility of the stone column will be less than the compressibility of the surrounding soil. So, that is written here. This compressibility of the stone column is less than the compressibility of the surrounding soil, which is obvious. If stiffness is more, then the compressibility will also be less compared to the surrounding soil. Okay, because here we are putting stones inside the soil, so that's why the stiffness of the material is more than the stiffness of the surrounding soil. That is for reinforcement function effects. Next one is the densification, and that is for granular soil, so which is called sometimes smear effect. What is that? The permeability and the compressibility of the soil near the stone column is less than the undisturbed soil due to the densification or smear effect. For example, for suppose you are the loose soil and loose sand, and within that sand we are installing the stone column. So during the installation there will be a densification of the surrounding soil, or surrounding soil will densify. Now, if the surrounding soil will densify, that means the some zone around the stone column that will be disturbed during the installation process, compared to a zone which is far away from the stone column that will be undisturbed condition. So, within the stone around the stone column there will be a disturbed zone and the undisturbed zone. I will discuss about the extent of this disturbed zone. Okay, all these things I will discuss, but right now you understand that there is a disturbed zone around the stone column due to the installation of the column. So that means this disturbed zone, or where the soil will densify, so that means if the soil densifies, permeability will reduce as well as the compressibility will also reduce. Now soil become dense, so the compressibility and the permeability of the disturbed soil as compared to the undisturbed soil will be less. Okay, because when the soil around the stone column will densify, their compressibility and permeability compared to the soil which is not been affected due to the installation, their permeability and compressibility is less. Clear? Because of this densification effect. So this is called the smear effect. Okay. Third one is the drainage, because the permeability, because here we are providing the stones into the ground, so the permeability of the stone column material is more than the permeability of the surrounding soil. Okay, that's why we are providing this drainage part. Next one is the another effect, that clogging of stone column due to migration of fine soil particles from soil to the pore of gravel, which reduce the permeability of the stone column. So in the drainage, another important thing is that, because when your excess water pressure is being generated, so that will dissipate through the column. So what will happen, that during the dissipation, the fines which is present into the surrounding soil, or fine soil particles, that will also travel with the soil, and these fines with the fine soil particle that will travel with the soil, they will enter into the stone column, and then they will block those pores of the stone column. So that is called clogging. Now, because of that, what will happen? If we block the pores of the stone column, so definitely the permeability of the stone column will reduce. So the effectiveness of the stone column to act as a drainage part, that will also reduce. So these four things we will consider during the design. Okay. So out of these first 2 and 3, the first 3 cases will be considered, and fourth one can be prevented. Okay. So we will discuss one by one. So that means there is a reinforcement effect, there is a densification effect or the smear effect, there is a drainage effect, that means the permeability of the stone column is more than the permeability of the soil. Then the stiffness of the stone column is more than the stiffness of the soil, or the compressibility of the stone column is less than the compressibility of the soil, and due to the densification effect, the permeability and compressibility of the soil near the stone column is less than the undisturbed soil, which is called the smear effect. And these 3 cases of effects will be considered during the design. But there is another important thing, that is the clogging of the stone column, that may reduce or can reduce the effectiveness of the column as the drainage path. So that will also be discussed. Okay, so in the next class I will discuss about this, how we can consider all these effects. That means this reinforcement effect, densification effect, or drainage effect. So these three effects, because this is here, this technique, all these three effects out of 4 except the solidification, other 3 effects are being considered here, or we will discuss all these effects and then how we can incorporate this effect in the design. That will be discussed in the next class. Thank you.